Everybody loves the idea of a small off-grid cabin, just a little place you can go to get away from the rest of the world. Now, whether you want to live off-grid full-time or just have a cottage somewhere for fishing or hunting, this video is going to cover every aspect of construction on the 4 cabins I've built over the last few years. And while these 4 cabin projects have their similarities, each one is unique in its own way, using different methods, different materials, different foundations. So let's dive right in. Hopefully you'll get a ton of good ideas. My name's Dave Whipple, and you're watching Bush Radical. Now we're going to be covering these 4 cabins: a 20 by 16 log, a 10 by 16 box, a 12 by 12 with a peaked roof, and a 10 by 12 with a shed roof. Now we're going to jump back and forth between these cabins during different phases, but let's start with the simplest one first. Now the foundation for this cabin is going to be 9 concrete discs. 1 at each corner, 1 at each midspan, 1 right in the center. They're about 4 inches thick and about 16 inches in diameter, and what they're generally used for is when poles are set for a pole barn, these go down in the hole to the bottom of the hole and basically provide a footing for the post. We're going to put these right on the surface. This piece of ground is fairly level, has a very gentle slope to it, and this cabin is going to be very close to the ground. So pads on top of the ground with a very short post is all that's necessary for a site like this and a tiny cabin like this 10 by 12. Now this is a very experimental foundation. You're not going to find it in any of the books, but it has held up very well in the 4 years this cabin's been in use. But it's only conducive to something really small and really close to the ground. If you had more of a slope, you would end up with a much taller post on one corner, and the higher up off the ground, the more leverage the movement inside the cabin or movement from wind would affect that post and its stability. One of the questions people are going to ask is about frost heaving. Being that all these discs are sitting right at the top of the ground, any frost movement is going to move the entire cabin. And with this cabin being 4 years old at the moment, I've seen no movement at all in it. The process is super simple. Just locate the 4 corners of the cabin, dig down through the roots and through the grass mat until you're just into good clean mineral soil, make it flat, put the disc down, pack the ground around the disc, and then you have a footing that you can start to build off of. Once the 4 corner footings have all been placed, I put one mid-span, halfway between each corner on the ends, and then I put one in the middle in case I ever wanted to stiffen the floor up a little. From this point, we can start building our floor. We're going to start just by building a simple box, 10 foot by 12 foot. Now this is a little bit convoluted, but it seemed like the right way to do it at the time. We built the box and then pulled it up so it was level on just some temporary supports. Now what this did was it gave us an opportunity to nail in all of the floor joists and then measure down from the existing floor so that we could cut each one of our posts to be exactly the right height and then fit them in one at a time. Now this is a good time to note that we're using rough cut lumber for this particular cabin, and it's a full 2 inches thick, so don't buy any of those coated sinker nails, 16 penny from the hardware store. You're going to want some solid 4-inch galvanized spikes. Regular 16 penny nails aren't long enough to go through this full 2-inch thick lumber and hold well. Now for the posts for this cabin foundation, we're going to use 6 by 6 green treated, ground contact rated pressure treated lumber. Having that floor temporarily suspended gives me the ability to measure it in place, and then I can cut each one of these posts to be the exact right length. The top 6 inches of that post I score so I can knock the chips out. I score it 2 inches deep because we're using full 2-inch thick floor joists and rim joists. Then just knock the chips off. It's a very straightforward process. Clean it up just a little bit and you will have a post that has a notched area that's at the exact right height. You can set it into place. Just take out the temporary brace that's holding the floor up. Set the finished post in place and it'll key right in. The notch in the post also gives the floor a flat, recessed area to rest on top of the post, which makes it a nice jointed fit. By the time this floor and the posts were all nailed together and finished, it was very rigid, but you could always overkill it by putting some 45-degree braces and make it even stronger. Once all of the posts were cut and fitted and nailed into place, each one of them got a gusset on the outside, nailed off not only to the rim joist but also to the post, and ultimately it turned out to be a quick, easy, strong foundation. Now for the 12 by 12 cabin with a loft and for the 10 by 16 cabin with a porch, I used the same foundation, which has become my favorite. This is just a treated post foundation, sunk into the ground. It's exceptionally rigid and it's very quick to build. Starts out very simple. Just figure out where you want your cabin to sit, pick a corner, dig a hole, and stick that first post in. You want to get down as far as you can. 4 foot would be ideal, but with a post hole digger, that's really a stretch. Get it down as deep as you can. I've never had any issues with frost, so I wouldn't worry so much about that. This is, after all, just a little hunting cabin in the woods. Now you want that first post to be not only packed in nice and tight, but make sure that it's completely plumb, straight up and down. From there, you can set the second post. It has to be the correct distance away from the first one, and it also needs to be completely plumb. So it takes a bit of wiggling. Sometimes you have to enlarge the bottom of the hole so you can get it both plumb and the right distance. This cabin is 16 feet long, and there's going to be a board that's sitting on the outside of these posts. So the posts are actually 15 foot 9 from the outside to the outside of the posts. And in the other direction, the 10-foot span of the cabin, they're going to be 9 foot 9 from the outside of the post to the outside of the next post, front to back. And you can see that that rim board is sticking out 1.5 inches beyond. That's going to make up that little bit of extra room, giving us a full 10 by 16 feet when we're done. Now the first 2 posts are critical, but the third one is really the post that matters. The third post has to be square. If it's not, you're going to have a parallelogram as opposed to a rectangle, and you don't want that. Now the mathematics to find the square, the diagonal of a rectangle, any certain size, it's its own subject, so I'm not going to cover it here, but you're going to need to work out the math of what that diagonal needs to be before you start pulling tape measures to get it correct. So do the math, find the diagonal, and then with just a couple tape measures you can find the exact spot that you need to set that post. Double and triple check that third post to make sure it's perfect before you pack it in. And then you can set the fourth post very easy. Just a couple tape measures and the basic numbers. Once you have in your 4 corner posts, you can do your layout of your floor joists on your outside joist, your rim joists, and then set in any additional posts mid-span. This particular cabin has 2 mid-span. The 12 by 12, it only has a single one mid-span. From there we can clean off the top of those posts, and then we can set in our ledger board. Now, that's one of the most interesting things about this foundation. It has a rim joist, the outside joist, and then it has a ledger that's on the inside. Now that ledger's taking a lot of the weight from the floor joist, so you don't need joist hangers. Not to mention that when we build a wall, the weight of the wall is going to be sitting on top of the posts. So the floor is really not carrying any weight of the walls or the roof. Pretty interesting little setup. Now my brother built his cabin like this about 4 years ago, and I stole the idea because I loved it. Now if it wasn't for the time that it took me to do all the film work to capture all these shots, I probably could have built this foundation in about 4 hours. Very quick, very simple, very straightforward. Now of course the posts go in first, the corners are the most important, and then the rim joists can all be set with a level, or with a laser level if you have that. That also gives you an opportunity, once you've done the layout of where the floor joists are going to go, when you dig in those extra posts, you can put them right beside a floor joist, which just makes this incredibly strong crib type of effect. You can also avoid the mishap of putting in a post mid-span and then having a floor joist land on that exact spot by doing your layout first. Now on the vertical log cabin outside Fairbanks, Alaska, the foundation was completely different. Being that a log house is extremely heavy, and being that it was on quite a slope, it needed a very solid foundation. This would have been a good candidate to actually put in a block foundation, a basement, or a poured crawl space. But the building site for this cabin is up a mountain where you cannot get a concrete truck in, or a block delivery truck. So what we ended up doing is doing individual concrete pads and concrete posts. I started out with 4 corner pads. Each one of these is about 32 by 32, and it's about 8 inches thick, and it's got a little mat of rebar in it. 2 bars going one way, 2 bars going the other. Once I had the 4 corner pads poured, I poured mid-span pads, and then started pouring concrete columns on top of each one of those pads. I hauled good quality gravel from a local pit, and mixed the concrete in the driveway with a hoe and a wheelbarrow. You can see that plastic water barrel right there in the back of the truck. I would fill that from the pond at the gravel pit, 1 bucket at a time, and then bring it up to the site with a load of gravel. Not ideal, but it's a way to get a concrete foundation in a place where you cannot get a concrete truck. Post and pad foundations are very common in interior Alaska, especially on soil that's questionable. The idea being if the ground moves, the building can be re-leveled using plywood shims between the concrete column and the floor system. This ground is actually really good quality ground. It's very rocky, it's very stable, but unfortunately there's no way to get a concrete truck up this mountain and up this mountain trail to pour a better foundation, which is a shame because this ground is conducive to a basement or to a slab on grade, and we ended up settling for a more of a cabin type foundation just because of the access issues. Now, one thing we need to talk about with a log cabin floor, you need to triple up your outside joist, your rim joist that goes around the perimeter. It needs to be 3 thick at the very minimum because you're supporting a much heavier building. Now you can see in this picture I built a standard box for the floor with just a single rim joist. But once the floor was built, I wrapped another rim joist around the outside, glued and nailed, and then wrapped a third rim joist. You can see that there's space over top of the concrete columns for that second and third rim joist to go all the way around. Now all 4 of these cabins have a standard wooden floor with rim joists and just standard joists, the only exception being the log cabin, which has a triple rim joist. After that, you're ready to insulate and deck the floor. With the black cabin and the 12 by 12 cabin, what we decided to do is put in a bottom drawer type of a system to insulate the floor. We used 2x2s nailed to the side of the floor joists and then dropped in basically plywood drawer bottoms. The decking on the top of the floor is of course going to seal the top of the floor, but underneath, without some way to cover the bottom of the floor system, the squirrels and the mice will take all of your insulation. A drawer bottom system like this allows you to seal off the bottom of the floor without being underneath of it, which is a big plus. Once all your 2x2 strips are nailed in place and all of your drawer bottoms are set in place, then you can roll out your insulation from up above. But I've found an even better way to do this is to install a drawer bottom and then insulate that section, move back, install the next drawer bottom and insulate that section. That way you're always working right next to yourself and you don't have to actually get up on top and walk on the floor joists to put the insulation in. Just do one little section at a time, drop the drawer bottoms in, screw them all off, do the insulation, and then move to the next section. This is probably the easiest way to seal up the bottom of a floor system that I've ever found. Beats the heck out of getting underneath of it, that's for sure. As with all insulation, make sure it's tucked in very neatly. You should never slap insulation in. You should always make sure it's tucked in nice so there are no gaps. Now, if you want the most insulation possible in a floor, you're going to want to fill the cavity between the floor joists with the thickest insulation that's allowable. Like for this, if I'm using a 2x8 floor joist, I'm going to use 8-inch insulation, and then I have to go underneath so I don't crowd the space of the insulation and have to squash the insulation, which is, of course, ruining its R value by compressing it. In this particular instance, I nailed on plywood sheets from underneath of the floor so I could use the full thickness of that floor cavity to put a full 8 inches of insulation in. I have to say, this is a terrible job. It's very stressful. You have extremely limited space. You're hammering nails into the bottom of a floor over top of your head. I would not recommend it. There's got to be a better way to do everything. And even though this does allow you to get that full thickness of insulation allowable for your floor joist, man, it's a pain in the neck to do. And then, of course, when you do install the insulation, like I said before, make sure it's tucked in very neatly. Cut around any obstructions so you have a good, firm, precise fit. The better you install the insulation, the better it's going to be able to do its job, the warmer your cabin. Just take your time. Now, when it comes to decking a floor, I like to use tongue and groove plywood. The idea with tongue and groove plywood is that it locks together one sheet to the next. So the spaces where the plywood butts together between the floor joists are not going to separate from each other. You're not going to have one that warps up and one that warps down, and you're also going to have a structural stability to that joint that helps to just make a nice stiff floor. And you're going to want a floor that doesn't have any irregularities to it, and tongue and groove is going to help you out with that. However, in the black cabin project and in the cabin with the porch, we ended up doing a finished floor of pine boards. Now the pine boards are they're going to make for a nice solid floor, and it's not so important that the plywood locks together if you're going to cover the floor with a heavy plank. But if you're going to use like a snap laminate flooring, tongue and groove is pretty critical because it will lock all the floor together, keep the floor very flat, conducive to linoleum, carpet, or snap laminate, and provide structural stability where one sheet of plywood butts into the next. As of today, 3/4 tongue and groove OSB is about $30 a sheet. High-end 3/4 inch water repellent tongue and groove plywood is about $45. Now, if you're going to drag a project out any amount of time, seal your plywood up with some kind of a water sealant, and then make sure you keep your floor system covered up with a tarp. The longer a project is drug out, the more opportunity rain can damage your subflooring and also damage the insulation underneath of it. So when you do get your floor done, treat it and cover it. Now, the best practice here is to glue down your plywood subflooring with construction adhesive on the top of each of your floor joists and then screwing the plywood down. That would be the best practice. You don't really need the construction adhesive. You don't need the extra strength from it. You don't need screws either. You can always nail off your subflooring like I'm doing here. You may get a floor that has a few squeaks, but that's kind of charming too. Now let's build some walls. On the black cabin, we started with the back wall. Now this is the simplest of all walls because it has no doors and it has no windows. Not only that, but it's only 6 foot tall in this particular cabin, so it's lighter than your average wall. We're using a 2 foot on center layout. Our roof is also going to be a 2 foot on center layout, so the roof rafters are going to land exactly on top of these wall studs. Now laying out your top and bottom plates for a 2 foot on center wall, you start at the very end, and then at the 2 foot marks, you don't mark the center, you mark 3/4 of an inch either side of 2 foot, 4 foot, 6 foot. That way when you nail on your plywood sheeting, it's flush to the edge, and the other edge of the plywood lands right in the middle of a stud. Now, standard practice in framing is to build an L for each corner. This is 2 2x4s nailed together, and then that goes in as your far end stud. What this is going to do is it's going to give you extra framing material to fasten your sheetrock to or your tongue and groove once the wall is completely built. Also makes for a good solid corner. Now, windows and doors need extra framing, and it's a good idea to build these as like sub-assemblies. So you build them first and then set them in place in the wall between the top and the bottom plate. It keeps you from nailing sideways in limited space. If you don't build your windows and doors first, it looks like this. You have to nail on an angle. Now on the black cabin and on the 12x12 cabin, I use T111 for the siding. The benefit of T111 siding is it's got the structural integrity of plywood, but it's also got this veneer that looks like up and down boards. So it's decorative, it's a finished product. All you have to do is stain it once it's up, and you don't have to worry about covering the building in like a vinyl siding, for instance. One thing about T111 though is a lot of the nailing areas are going to be down in the valley, so you have to set the nails with a punch. Now in any conventional framing, you're going to have to stand up the walls. It's always better to do this with as many people as you have, but it's not necessary. A short wall like this, that's only 12 feet long, it's only 6 feet tall, would be really easy to stand with one person, provided the person's, in decent physical shape and has a little bit of strength. You can pick the wall up, set it in place. Now, the first thing you want to do when you stand up a wall is get a brace on it. That will hold the wall upright. If you've never built anything before, this is the first thing to keep in mind. If you've built before, of course, you've been through this. You can always tack that brace in temporarily and then go back, undo that brace once the bottom plate has been nailed off, and then make sure it's completely plumb, and then re-nail it. So if you're working alone, how much wall can a single person stand? On this 12x12 cabin, I'm standing walls that are 12 feet long, 8 feet high, full 8 feet high, and they have window and door framing, so they're a little extra heavy. This wall is 16 feet long. It has window and door framing, and it's pretty much too much for one person. I had a terrible time trying to get this wall up, and I ended up cutting the plywood out from the window opening, the large window opening, just to alleviate some of the weight. On my first attempt to stand this wall, I did not feel that I could safely stand this wall. It was too heavy. It was too awkward. Once the extra weight was cut out of the window opening, I could stand this wall by myself. Now, to give you a frame of reference, I'm 6'2", about 235 pounds, and when I built this particular cabin, the cabin with a porch, I was 45 years old. So if you've never built anything yourself, keep those numbers in mind. Hopefully it'll give you some idea of what you could get away with or what you might need more people for. Well, now let's take a look at building log walls. Now there's several different ways that you can fit logs together. You can scribe fit them together. You can mill them so that they have flat sides and they just sit flush with each other. You can stack them up so they have large gaps between each log, like you see Appalachia style log cabins where they mortar the joint between the two logs. But in this particular instance, we're doing a vertical log cabin. We're using 8-foot logs that stand straight up and down. In this particular style of cabin, you could scribe fit one log to the next, but it'd be a terribly tedious process. So what we're doing here is we're milling two sides of a log flat. And we're also starting with corner logs that are milled at a 90-degree angle. So you have a natural log face on the outside, and the other two sides are basically like a beam. Now, with any kind of a log cabin, you have a couple options with how you deal with the logs. You can stand logs up green. You can season logs and then stand them up. But what you can't do is mill logs green and allow them to season and then stand them up. Now, let's put aside scribe fitting for a second. We'll just talk about milled logs. You have about 3 options in milled logs. The most processed log you can buy is actually cut like a dowel, where it's perfectly round, and a lot of times they will mill a keyway, a channel, into the top and the bottom so they lock together. That is a very processed looking log, and even though it does look like log, it doesn't look natural. The other options are 2-sided logs and 3-sided logs. A 2-sided log is flat on 2 sides, and of course a 3-sided basically is a beam with one of its faces being the natural log face. Whether you're building a horizontal cabin or a vertical cabin like this, you're fitting in one log at a time. And of course, the most efficient way to do this is to plan your windows and doors ahead of time. This way you're making the most use out of the logs you have. You have the least amount of scrap and the least amount of work. I've found over the years that building with log is very therapeutic because it's abstract. It's like concrete work or painting. You're not dealing with precision dimensions and standardized materials. Every piece is unique. Every log is unique. Every log has its own characteristic and look, and it's just a fun way to build. All of these logs are held together with log screws. Now, if a log screw is a foot long or 4 inches long, it only has about 2 inches of threads on it. So no matter how long the screw is, only 2 inches of it are actually biting and holding. So if you're putting in an 8-inch log, use a 10-inch screw. If you're putting in a 12-inch log, use a 14-inch screw. Now, how many logs do you need? Well, for this cabin, I'm using 2 sizes. I'm using ones that are milled 6 inches wide, and I'm using ones that are milled 8 inches wide, depending on how much wood I can get out of a particular section of a tree. You always want to get as much as you can. Don't take a big log and mill it down to 6 inches, and don't try to get an 8-inch log out of a smaller log, or you'll end up with really, really small flat spots on each side. If you're buying logs that are milled all the same size, you take the lineal footage of the wall. This cabin is 72 feet, for example, because it's 16 by 20. You would times that by 12 to get your lineal inches, and then just divide it by 8 or 6 or whatever size logs you have available. Now, with standard stick framing, 2x4s, 2x6s, you're always going to stand up one wall first, whichever wall that is. In this case, we stood the back wall up first, then we built the front wall and stood that up. So you'll often have 2 opposite walls that you stand up first, and then 2 more walls that need to be built and stood up afterwards. Why do I even bring this up? Well, the 3rd and 4th walls need to be built differently. Whether you're building a shed-style cabin, like the black cabin and the porch cabin, or whether you're building more of a conventional box, like the 12x12 cabin. Allow me to explain. The first wall goes up, and then the second wall goes up. Both of these I've sheeted before I stood them. Now on the 3rd wall, I can't sheet it because the sheeting goes beyond the dimensions of the wall I'm building. So the wall has to be built as just a frame. And then I can stand the wall, and I'll have to sheet it standing up. Now the good news is it's very light. It's very easy to stand up. I'll get that wall put into place and then nail it off to the front and the back wall, which I've already stood up. Of course, I'll nail the bottom completely off too. Always double check that you're still plumb before you nail off that wall. Now once this third wall, which is just a frame, is nailed off good, we can start sheeting it from the outside. The way to make this easier is to nail off a 2x4 right along your rim joist. That'll give you something to set that plywood on top of. Just an easy way one person can get it in place and nail it off without help. Well, the fourth wall is the same thing. It's got to be on the inside of the other two walls, so it definitely can't be sheeted. Stand it up, sheet it, done deal. Now on the black cabin and the porch cabin, the end walls are on an angle, so you can't build the wall and stand it. Each part of the wall needs to be put in individually. Individual studs, individually cut. Of course, the plywood sheeting on the end walls needs to be cut to match that pitch of that shed style roof. It's definitely a much slower process. Now on the black cabin and the porch cabin, I cut each end wall stud and notched them so that they would key into that rafter, the one that's on the end of the wall. Now this is plenty strong for a little cabin like this, which is just a very small recreational style cabin. But I wouldn't recommend doing it this way, and I'll tell you why. Until you have your roof mouse-proofed, that is, the little ribs in the metal and the bird blocks, until they're mouse-proof, mice can get in your roof, and they love to do that, and they can go down those end walls. So if you do build this style, put a block between each end wall stud. Well, now that we've talked about building and standing walls, let's talk about the second story floor. The log cabin is the only one that has a proper second story. Now, vertical log is a bit uncommon, and this is the first and only one of these type of cabins I've ever built. So fitting in the logs that hold up the second story floor, well, it was kind of just a trial and error process. Again, I'm using trees cut right from the property. I'm taking and milling one side of them flat so that when the flat side is facing up, it'll be a nice flat nailing surface for the plank floor upstairs. I'm also milling a 6-inch wide flat section on each end because these first couple logs are going to sit over headers that I've already installed. Now, I'm sure there's a better way to do this, but because I started with corner posts and then installed a double top plate all the way around the building, I'm fitting in the walls between the top and the bottom plate. And I'm actually having to pull these logs up to that double top plate after the fact, which is kind of different. And I don't know that this is the right way to do it. I'm sure there's a better way to do it. But this cabin is an unconventional style, and therefore it requires a bit of unconventionality. Fitting these logs was just a matter of lifting and holding with a rope harness. That's all improvised, but it worked out pretty good. Only took me a few hours to fit every log in and get ready to put in that upstairs floor. Now on the 12 by 12 cabin, I didn't do a full loft or an upstairs, but I did do a half loft. For the half loft, I started with a standing dead spruce tree. And this is a very dead tree, but it's very structurally solid still. Now, anytime you can add a decorative element to your build, whether it's a beam or a post or a girder, log is always nice. Everybody loves the look of log. It's time-tested, proven. Not only that, but a log in and of itself is reliably strong and structurally sound. You can't do better than just a big giant wooden pole when you need to hold something up. And in this instance, we're going to be holding up the loft in this 12 by 12 cabin. Now, as opposed to using a chainsaw jig like we've done for our vertical log cabin, I'm just eyeballing this cut, using a straight 2x4 as a guide. I'm keeping the bar of the saw about 1/4 of an inch off of that 2x so I don't hit the 2x and damage it. But what I'm doing is just making nice, slow, even passes along that log until I've got that face milled off. It's pretty easy to make a good cut this way with just a little bit of patience. Then we'll go ahead and peel our log and get ready to set it in as a structural and decorative element holding up our loft in that 12 by 12. Now, of course, you don't need to use a log. You could use a 4x6 or maybe get by even with a 4x4. But a log is super solid, and if you have some trees, it's likely free. Everybody loves the look. It's just a great little addition to a build. Now, I'm nailing this log in to the header over top of the window. Now, the nails I'm using here are about 10-inch spring steel, ring shank style barn spikes. It's basically just a long spring steel nail. Takes a bit to drive them in, but you're never going to pull them out. Now, this log is sitting on 2 window headers, but I'm going to need another log. So for this particular design, I wait until later in the process to install the second log, and I'll show you why here in just a second. That first log had to be put in place before I sheeted that wall, but the second log doesn't necessarily need to be. The reason the first one had to be put in before the wall was sheeted is because it sat over top of those windows, and I would never be able to get it into those spots once there was sheeting on the outside of the wall. The second log for this loft is going to be set in on this little bit of framing. I put in 2 trimmer studs and then a sill plate, and then I put in a double sill plate so that that log is going to sit at the exact same height as the first log. I lift the second end up and then put my block in place, rotate my log to where it needs to be so it's sitting in there proper, and then I can nail off that second sill plate. And then we'll just have to lift her on up, fit in our double sill plate so that the height matches the other log, just like that. Set that log down and we can nail her off. Now let's talk decks and porches. For the cabin with the porch, I went with a 5-foot wide porch. That's plenty of room to sit on with a chair, have a nice little roof over it. You're going to have not a lot of space, but more than enough. Now I'm using 4 4x4 treated posts for the support of this porch. You can also see that I've put joist hangers along the rim joist of the existing structure. First thing I'm going to do is I'm going to set in these corner posts, and I'm going to make sure they're at the right distance apart and that they're square to the building. Then we can set in the outside rim joist and then fill in the area with our short 5-foot joist. For this, I'm buying 10-foot material, of course, and cutting it in half. All the wood used on this porch is treated. Make sure that you get ground contact treated 4x4s if you're going to sink them into the ground. And then for the decking, of course, we're just going to use 1¼ deck boards. And these are supposed to be 5/4 of an inch, 1¼ inch, but they're actually closer to just an inch thick. But if you just bought 1-inch boards, you're getting a 3/4 inch board, and that's really not enough. As long as you have a roof over top of your porch, you could get away with just standard lumber, 1.5-inch lumber, but it's a little bit overkill as far as structural stability for a deck. And you're going to have a porch over it, or otherwise it's going to be exposed to the weather, and you don't want that if you're just using standard lumber. Now I'm screwing this deck down. A lot of people ask why screw the deck down and nail everything else off. Well, I don't want those screws to come backing out, so you could maybe catch them with a bare foot. Screws won't back out, but a nail might. So screwing off the deck is the right thing to do. For everything else, I just prefer nails. One question I've got 1,000 times is, why don't I screw everything? Well, nobody has done that up until recently. Now, when you're talking a heavy-duty screw that has the shear strength of a nail, you're talking about a pretty thick screw. And for just standard framing, especially where you have to toenail something on a diagonal, you're going to run the risk of splitting your wood more than it's going to help by having a screw in it. Nails are standard. They've been around for thousands of years. They work. No real reason to reinvent the wheel on that. But on a deck, where it's exposed to the air, it's exposed to the wind, it might get wet, you could have a chance of a nail backing out, and then it's of course a hazard for a bare foot. Now for the 12x12 cabin that has an exposed deck that wraps around a tree, I started with floor joists up against the existing building, just like the previous, and then I built a box and suspended it temporarily on some temporary 2x4 supports. Then like the black cabin, I did on-grade foundation supports just with a couple 4x8x16 cement blocks set on level ground that's compacted. Then I set in notched posts just the same way we did with the black cabin. From there, the decking is the same as it was with the porch cabin. The only difference is I had to cut out around the spruce tree. A lot of people have complained about this idea because they say the tree's going to grow, the tree's going to die, the tree's going to fall over. Spruce trees are quite stable. Now, of course, it could die. It could blow over in a storm. If that were to happen, what I would do is just remove the deck boards with the cutout for the tree, cut the stump off, put new deck boards down, and then probably put a roof over top of this porch, which would be a lot more enclosed space that's out of the weather. But I like the look. I like the whimsical aspect of having a tree in your deck. And as far as I'm concerned, it's going to be just fine until it's not, and then I'll worry about it and change and evolve the cabin. Now let's move on to roofing, and we're going to talk first about our shed-style roof. Now 2 of these cabins have a very simple shed-style roof with just one set of rafters. It has no peak, and it's just more or less flat, but on a slight angle. Now for this type of a roof, I'm going to cut 2 bird's mouth cuts in each rafter, one for each wall. And then that rafter is going to sit down in that bird's mouth cut nice and flush. To make the cut, I use the best, straightest rafter. I get that one cut ahead of time and then just use it as a pattern to cut the other additional rafters. I always use a skill saw to make the most of the cut that I can, and then use a handsaw to finish it up. That way you're not over-cutting that joint. You're only cutting out as much wood as needs to be cut out to get that chunk out. If you overcut that rafter, you're just weakening it. So it's always best to finish it up with a handsaw. So how do you know how to make that cut? Well, let me show you. We're going to take our best, straightest rafter and we're going to set it up on the wall. Make sure your front wall and your back wall are perfectly plumb. Set the rafter in place and then make sure your overhang is where you want it, front and back. Now I'm going to take a speed square here, or you can use any straight edge or a scrap of wood, whatever you have, to mark a line parallel with the top plate of that wall. And then use a level on the back side to make a vertical line. This will just give you the mark that needs to be cut out of that rafter. Just repeat the same process on the other wall. You see that little stick and clamp? That just holds it from moving front to back. So I can make sure that I don't mark it on one end and then have the rafter slide a little bit and put the mark on the wrong spot on the other end. Once both bird's mouth cuts are made, make sure it's a good fit. Then you can use that rafter as a pattern to cut your other rafters. But how big should that cutout be? Well, check your gap. This gap is 3/4 of an inch, so I would use a 3/4 inch piece of plywood. The ideal situation is that that cutout will go all the way across the top plate of that wall, but no farther. Cut out too little, you don't have good contact all the way across that joint. Cut out too much and you've cut more wood than necessary out of your rafter. Once you've made the perfect bird's mouth, that's the perfect size, use that rafter as a pattern, cut all your other rafters, you're good to go. On the log cabin in the 12x12, we're going to need to build the roof, but we don't have anything to work off of. And because it's essentially a 2-story cabin, we're going to have to use some kind of scaffolding. You can rent scaffolding, you can buy scaffolding, or you can build scaffolding. What we're doing here is I'm building a makeshift scaffolding using 2x4s, ledger boards on each end of the wall, and that log support that we just put in a little while ago. At this stage, I actually only have one log in there. It's at the mid-span of the building, about 6 feet from the front, 6 feet from the back. And it's going to hold all this weight without any problem. Now the plywood is going to be used for the gable ends of the roof. And the 2x4s are going to be used on the roof for nailers. So I'm basically making makeshift scaffolding with materials I already have. Same goes for the log house. I nailed in a ledger and then nailed in the 2x4s to the ledger so it couldn't move, then decked it with OSB. Now on the shed style roofs, you can just work off the ground or work off a small step ladder, but on a building like this, we're working at an elevated height, basically a second-story floor. And if you don't have a second-story floor, you'll have to either erect scaffolding or build some kind of a scaffolding to work off of in order to install the rafters to build the roof. Now on the 12x12 cabin and on the log cabin, I'm using a peaked roof, which has 2 rafters that meet together in the middle. You could have a ridge beam that runs the full length that the rafters nail into, but I'm using gussets. These gussets will hold the 2 rafters together, and then when I put the 2x4s on the roof that the metal will screw down to, everything will be held together in a rigid roof system. I like doing raftered roofs this way for a couple reasons. You don't have to set up a ridge pole, and you can build your rafters into a big V with the gussets holding the peaks together and set them up in pairs. I think this works out pretty easy, and it's quick. It's just kind of self-explanatory. Now, if you're standing rafters up in pairs like this, it's a good thing to nail them off as soon as you get them up. Check your spacing to make sure that you're exactly 2 feet on center. Move your rafter pair to where it needs to be, and just put a nail in it. Doesn't have to be permanent. Just tack a nail in there to hold it in place. And then you can go down and nail off the bird's mouth, where it sits on the top of the wall. Now there's a little bit of math involved in figuring out the angles and where the cuts go on a matching pair of rafters like this. I'm going to save that for another video. Right now let's talk about bird blocking. Bird blocking not only makes your rafters extremely rigid, but it's also going to keep out squirrels and rodents and anything else that wants to get up in your roof. A couple ways to do bird blocking. This bird blocking, the outside of the block is flush with the outside of the wall. They're nailed into the rafters and they're nailed through the top plate of the wall, into the bottom of the bird block, because this shed style cabin doesn't have a double top plate. But on the 12 by 12, it does have a double top plate. And you can see I've left my plywood 1.5 inches down from the top of the wall. So I nail off my rafter. I actually set the bird block on the outside of the wall and nail it into that second top plate, making a nice tight joint with the siding and a good solid nailing into that plate. Finish it up with a few toenails into the rafter. It's not going anywhere. No matter what style cabin you build, as soon as you have the roof on, the best idea is to weatherproof it. And maybe the best solution you have to that is to put a big tarp over top of the whole building. That's going to keep water off your floor and out of your floor insulation. No matter what you do, keep everything as dry as possible. Now, just like the end walls on a shed style cabin, these gable end walls need to be built one stick at a time. Once we have built in the framing in the gable walls, we'll have to sheet the gable ends. Now, I have a lifelong distrust of extension ladders, so I do most of this work from inside the building, hanging out over that end rafter with the rafter up against your hip. You're in a very secure position. One of the most beneficial things you can have in this circumstance is to have a hammer that has a recess on the top with a magnet to set a nail. That way you can reach out over top, set your nail with only your hammer, and drive it in with the hammer without ever using your left hand to hold the nail. Now, to make the cuts accurately, you just set the plywood in place and then mark it. Come back down and then make the cut. As opposed to guessing angles or trying to do math, put the material in place, mark it against what's existing, make the cut. Now, as opposed to doing this roof in OSB or plywood, covering completely, and then tar paper, and then shingles or metal, I like to skip sheet my roofs. That's a nailer about 24 or 16 inches on center that your sheet metal roofing will screw down to. Now, whatever drawbacks there might be to skip sheeting, some people will say there's condensation issues. Some people will say that it's not as structurally solid as plywood. Whatever the drawbacks are, there are benefits. One of those benefits being it's safe to work on a steep roof that's skip sheeted. I've never had any issues with condensation that's caused mold or water damage or anything like that. Now, a roof will sweat from underneath with the right conditions, temperature, and moisture, but it'll also dissipate with ventilation. As long as there's good ventilation through the roof itself, it shouldn't be a problem. Now, I'm not a professional roofer, I'm a hobbyist roofer, but this is the way I prefer to do it. If you've never roofed a cabin before or a house, I'd start with metal roofing. It's fast, it's easy, I love the look of it, and it requires almost no tools. Now, the first metal roof I did, the manufacturer of the metal, told me to put the screws on the flat next to the rib, not on the rib. I've heard a lot of people say to put it on top of the rib, but then you end up with 1.5 inch gap where it's just screw, and the metal could potentially rock one direction or the other. Of course, it keeps the holes that you're putting with the screw from being right down where the water is on the flat. But I've been told by a manufacturer to put the screws on the flat. Grill me in the comments all you want. Everybody's got an opinion on this. This is the way I've always done it. I've never had a leak. Now, when you're doing metal roofing on a steep roof like this, I like to start from the bottom on a step ladder. This allows you to check your overhang on both sides of your roof metal and get it perfectly even. Now you can climb back onto the roof with the skip sheeting and finish off the screws. Repeat the process. Repeat the process, repeat the process. The hairy part comes when you get towards the end and you have to put those last couple sheets on because you've run out of stuff to stand on. I like to do as much as I can reach from a ladder, and I like to do as much as I can reach from the peak. But once you have both sides installed, you're kind of in a pickle. You have to work on the ridge cap, you have to finish up the screws, and you have to get off the roof safely. I'm not going to give you any advice on how to do this, but what I do is tie a 20,000-pound tow strap to the actual framing of the roof underneath the ridge cap and use it to climb down to a step ladder. This might not be everybody's bag, but I trust my hands and my grip way more than I trust an extension ladder. Of all the tools and all the construction jobs I've ever been on, an extension ladder is the only tool that's ever put me in the hospital. So even though it looks really sketchy to work off an improvised climbing harness sliding down the side of this roof while I put in the last screws, I can't even begin to bring myself to lay an extension ladder on a roof and then trust it to my body weight. Now, when you put on your roof metal, there's only two things you need to do. You need to get the first sheet as perfect as possible. Now, we slide that first sheet up the roof, and then you're going to look down the ends of all of your skip sheeting, and they should all be cut perfectly the same. And once that sheet is in place, you can get a visual look of how it sits. You also want to check the overhang to make sure that the overhang is correct on both ends of the metal, and then put those first couple screws in there. From there, as long as your building is square, every sheet should fall perfectly in place. Sometimes I use a chalk line to make a chalk mark from the top skip sheet to the bottom, and then make sure that they're all cut off exactly the same. Standard roof metal is going to give you 3 feet of coverage. There are lots of places out there that will cut it to a specific length for you, so you can get pretty much anything you want. Now we're going to insulate our walls. And for insulation, you don't have a ton of options. There is spray foam, there is a cellulose that has a glue component to it that can be sprayed into wall cavities. We're just using standard mineral wool, fiberglass insulation, whatever's available. The trick is, tuck the insulation in carefully. Make sure that it's tucked in with attention to detail and patience. You don't want any voids between your stud and between your insulation. You don't want any voids at the top end or the bottom end either. You don't really need to cut insulation oversized and cram it into the space available. Try to go for just about the exact amount of space. If it's a 48-inch cavity, cut your piece 48 inches. And then make sure that it's nice and even and there's no areas that are compressed and there's no areas that have a gap. Now, the good thing about log is that when your log is up, you have the exterior, you have the interior, you have the insulation, you got the whole shot. For every framed wall, you're going to need a wall covering. And personally, I hate sheetrock. I'd rather put plywood on the inside of a wall and paint it. Your mileage may vary, but for the money, for the time it takes, for the effort, I think tongue and groove is about the best way you can go. It is expensive, don't get me wrong, but it's not prohibitively expensive. A cheap brad nailer can be bought for $30, a cheap air compressor $40 or $50, and it takes only the smallest air compressor to run a small brad nailer. You can rock this stuff out. A wall like this might take you 30 minutes to install. But the beauty of a wood paneled wall is kind of hard to beat. Not only that, but you're dealing with small pieces. You don't have a 4x8 sheet that weighs 80 pounds of half-inch sheetrock. All of this is light, easy to handle work. It should be said also that sheetrock is easy to damage, it's very heavy, it's difficult to transport, and then it's a multi-step process. It needs to be fastened to a wall, needs to be taped, needs to be mudded, sanded, painted, and it always makes a giant mess. So there are a lot of different things you could put on an interior wall. I'm only showing you one of them here because it's my favorite, but it's the first material I would choose if given the choice. Now, when it comes to tongue and groove, here's my best advice. Only buy tongue and groove from some place where you can pick it out by hand. The reason is, every piece of tongue and groove that's bad, that's warped, that's cracked, or whatnot, the last guy is going to leave it there. And if you have it delivered, the delivery guy is going to bring you whatever's in the stack. And chances are most of that stack is going to be culled material. It's going to be tongue and groove that the last guy didn't buy because it sucked. And the delivery guy is going to take it all to you. So go someplace where you can pick it out piece by piece, spend the extra time and effort, and you're going to be glad you did. Now, getting around obstacles like these log loft supports, that's a little bit tricky. But tongue and groove is always made from pine or spruce. It's soft, it's easy to cut, it's easy to do specialty cuts like these ones here. And the finished product just turns out good. Also, when you're working over your head, ceilings are generally done with 5/8 inch sheetrock, which is heavier yet, and you'll need a sheetrock hoist to lift it up into place. You don't need that with tongue and groove. Now, like I said, with log wall coverings, the logs are done as soon as you put them up. But if you're using logs in the summertime, especially green logs, you will deal with mold. Mold can be washed off with just a little bit of bleach and water. Then once you have the logs all cleaned off, let them dry, and then they can be sealed up with whatever kind of log oil or log varnish you would like to use. Now, all these cabins have about the same stove setup. Two steel flanges with an 8-inch hole in the center, passing through a side wall. These two flanges support an insulated section of stovepipe. I generally just take a small scrap of wood and put two nails in it, about 6 inches apart. That way I can trace out, well, like a compass, the circle to cut out of the wall. Now I want to be 2 inches with the wood beyond my insulated pipe, so there's 2 inches of clearance. From there I'm going to put a metal flange on both sides of the wall. The metal flanges are 2 feet by 2 feet. You can buy these at a hardware store, Lowe's, Menards, whatever you have. Now the metal flanges are a physical support that holds up that section of insulated pipe. It's also fireproof, and I just generally leave the cavity inside around the stovepipe completely empty. These are small cabins, and a wood stove will cook you out of a small cabin, so there's no need to go overboard with insulation. If you did want to insulate that cavity, I would suggest you use a mineral wool. If you've ever seen the rope gasket that goes around the door of a wood stove, that's a mineral wool. Fiberglass insulation is readily available, but I generally would just steer away from it. I don't know, it just makes me nervous having something right up against that pipe in an enclosed area. From there I'll install, whether it's on the outside of the building, or in this case I'm slipping this flange behind the stud work. I'll put that flange on both sides of the wall. Here's a picture of my first cabin and its stove setup. It worked then, it's never given me a problem. I like to use it on every project. Now I pass this insulated pipe through the wall, put the second flange on, and then nail the second flange off to the framing. Now what I like to see is just a little bit of fall from the inside of the building to the outside. If for some reason there's rainwater that collects in the elbow of that pipe on the outside of the house, I don't want it to run back into the stove. Here's another cabin. This is a porch cabin where I'm doing basically the same project, basically the same way. Now when you fit together stovepipe, they got this kind of clip together style fitting, and I like to crush that down. It always makes it easier to get the pipe to slip one over the other, and it also leaves a lot less of a gap. We put this together with just some self-tapping screws to make sure it's all one unit and held together by itself. Once you have the outside section of stovepipe built, you can install it on the outside of the cabin. Once the outside pipe is all together, I'm going to start focusing on the inside pipe. And the big priority with the inside pipe is to install the damper. What you want to do when you install the damper is put a hole exactly opposite from one side of the pipe to the other, big enough for this rod to pass through. We drill that out, and then we're going to reach inside of the pipe, line it all up, and then pass that metal rod through that cast iron plate. Once you see it, it's pretty self-explanatory. It kind of locks itself into place. I like to make sure that there's a nice snug fit from the flanges to the pipe. I don't want to seal it off with any kind of a Lexol sealant or a high temp sealant of another kind. I just want it to be a friction fit. So I generally make sure that that is as snug as possible. Here's another shot of me making sure that that has some drop from the inside of the building to the outside. Once the outside pipe is in place, I'll grab a measurement from the wall of the building to the back side of the pipe, and also wrapping around the pipe. This way I can build the standoff. Now all the standoff does is it holds the upright pipe rigid. Any flat piece of metal that's long enough to do the job that you can bend is probably going to be just fine. Once again, this is like a 4-foot chunk of metal from the hardware store. I wrap it around the pipe and screw it off to the building. That way, no matter how bad the wind gets, that pipe's going nowhere. From there, we're going to work on the inside. We're going to finish up the pipe work just above the wood stove itself. Now, each one of these pieces has to be a specific length, so make sure that your stove is set up where you want it, and if you're setting it up on blocks or on masonry or pavers, put those down first so that the stove is at the correct height. Then you can make all your measurements, cut your pieces, and install your inside pipe. If you're working in cold weather and you want to install the stove to heat the place up while you're working, at least get it up off the floor on a couple blocks. This way you can use the stove while you work, and your pipe's going to be really close, so if you end up with some thicker flooring, you'll only have to take that pipe apart and trim it a little to make it right. Now, a word on wood stoves. If you buy a used wood stove that's been ran in somebody else's house or cabin and put up for sale on Marketplace, chances are it's going to be fine. But if you buy a new one, they're all coated with a high temperature paint. Sometimes the paint burns off quickly and easily, sometimes it doesn't. Almost all the time it will smoke and fume. Same goes for the black metal stovepipe that goes on the inside of the cabin. best to burn all this stuff off outside. This little stove is called an Alpine Camp Chef stove. You can buy these on Amazon for $250 and they come with pipe. Now, this particular stove took me hours to burn all the fumes off it. Even to this day, if I run the stove just a little bit hot in this cabin, that stove smells bad. Although it's nice to heat a cabin up really quick with a really hot fire, it's not necessary. Take a couple extra minutes. Don't overwork the stove. If you get it beyond a temperature that you've already had it to, a lot of times you'll start smelling the fumes from that paint. Two things you're going to want with a wood stove is you're going to want some kind of fireproof base under the stove, especially out in the front where coals are likely to fall out. Here I'm just using some 4x16 pavers. Now these are great big heavy blocks, but it's kind of nice to have the stove up just a little higher. It's a short stove to start with, loading wood and just sitting by it. It's nice to have it a little high. You can use just a piece of tin on the floor. You can use a mat that you can buy from the store that is designed for a wood stove to sit on it. Whatever it is, it just needs to be fireproof. Same thing goes with a heat shield between the stove and the wall. I like to just use galvanized metal roofing. Now let's talk about lofts and upstairs floors. Two cabins in this video have an upstairs, one a full upstairs and one just a loft. As opposed to doing any kind of a plywood or an OSB and then trying to finish it from the bottom and finish it from the top, I like to just use plain wood planks. It's a nice look above, it's a nice look below, put a good finish on it. By the time you install it, it's done. And all I'm doing here is just screwing it down to my log supports. Easy. Now a loft needs a ladder, so we're going to have to build ourselves a ladder for the loft. In the log cabin, it actually has an upstairs, so it currently has just a standard 2x4 ladder, but ultimately I'm going to build a set of log steps. That's going to look a lot better. It's going to be a much more permanent and a lot nicer addition to the log cabin. But for a cabin like this, a simple 2x4 ladder is all you're going to need. You want to do a layout on your 2x4s as to where you want your treads. If you're shorter, maybe you want them closer together. If you're taller, maybe a little bit farther apart. I'm cutting this 2x4 right now with an angle. The angle is the appropriate angle where it sits flat on the floor. Might take a little finagling to figure that out, but it's not too difficult. I screw the two sides of the ladder together and start cutting my notches. Cutting the blade on the skill saw about a ½ inch deep. These don't have to be inlet very far to add a lot of structural stability to the treads, but not decrease the strength of the 2x4s. Once I make the outside cuts, I'll go back and make a whole bunch of cuts so I can take the chips out. The outside cuts are made and you have all the fine inside cuts made. Just a chisel and a hammer, you can pop these chips right out. Do all the finish work with a draw shave or a chisel. Clean up those sockets really good, and then you're ready to screw in your 2x4 treads. I like to use 2 screws for each side, and the tighter the socket that those 2x4s fit into, the more stability the ladder is going to have in general. So when you do make your cuts for your ladder treads, don't make them too sloppy. Make them as tight as you can get them. Now the idea with a ladder like this is it's going to be fastened to the ceiling. I'm going to fasten it right through the tongue and groove into the rafters behind the tongue and groove, and then it's going to sit flat on the floor. As opposed to nailing it off, I'm putting it on a set of hinges so that when not in use, I can just fold it up. And with a simple hook, like you'd see on an old barn door, I can swing it up out of the way, hook it into place, and then it stays suspended way above head height until you need it. Now let's talk about windows. Windows and doors are the same in pretty much any building that you build. When you buy a window at a hardware store, the window is a ½ inch smaller than what it says it is. So if it's a 24 by 24 window, it will fit in a 24 by 24 hole and have a ¼ inch gap on the inside all the way around. And then it has a plastic flange on the outside. All modern windows basically. And you just caulk the edges of the opening, put the window in, make sure that it's centered in the hole, and then you can screw it off to the outside of the building. Now here you can see an inside view of how this window sits in the opening. This opening is exactly 3 feet by 3 feet, but the inside of this window is 35.5 by 35.5. So it has this gap all the way around it. You can fill that gap with spray foam and get a nice tight seal on those windows. What I'll do generally is put a little ¼ inch piece of wood on the sill of the window. So when I set the window from the outside, it's setting on top of a 1/4 inch piece. It should have a 1/4 inch gap on the top. Then you just move it left and right until you have it centered and the gap is the same all the way around. Then you can foam in the windows, wait for the foam to dry, trim the foam off, and you're ready to start doing all the trim work on the inside. Now on the black cabin, we had a very large pane of glass. So it wasn't a standard window. We actually built the opening for this window to fit a specific piece of glass, which was a very odd shape. We put a trim board on the outside of the sill. We set the pane of glass in that opening and then trimmed it out on the inside so that the glass was held in place by those outside trimmers and those inside trimmers. Now you can do this with any pane of glass that you have. It's a good idea to have an opening that's standard, 4 foot by 5 foot, 5 foot by 6 foot, etc. But if you do have a unique piece of glass you want to use that's an odd dimension, just understand if you break it, you'll have to either replace it with the same size pane of glass, or you'll have to reframe that area so that it'll fit a conventional window. You can see here we're screwing in the trim pieces that hold the inside of that window in. A nice big picture window like this is a wonderful thing, and there's nothing wrong with just a single pane piece of glass in a cabin this size. You're going to cook yourself out with a stove, so a double pane window or a triple pane window is really overkill. Now let's talk about mouse proofing. If you have a cabin, especially a remote cabin and especially a cabin you're not using every day, mouse proofing it is going to be an ongoing chore until you get it right. Mice can find a way into a house through the smallest opening. If they can fit their head through a hole, they can get their body through it. And they love to get up in your roof. So flashing any areas that they might climb on to get into openings in the roof is mandatory. Also, if you're using metal roofing like this, every one of those ribs is a perfect hole for a mouse to climb up into and get into your roof. Mice can climb on the smoothest plywood, they can climb up the corners, they can climb across your rafters. So a lot of detail and a lot of attention work is going to go into mouse proofing your building. Now what I like to use is just a hardware cloth. This is just a wire mesh. You can cut it with a set of 10 snips very easy. I make small individual pieces about 1.5 inches wide by about 3 inches long. And these are going to go up and be custom fit into each one of those metal roof ribs to keep it closed off from rodents. Just bend down the corners until one end of that piece of wire mesh is about the exact fit for that rib, and then staple it into place. It's basically like a steel cage to keep all the little critters out. But it also still allows the air to pass through to ventilate the roof. Now we're ready to start working on the interior. For flooring, I just did a board plank floor in the porch cabin, and Brooke installed the same type of floor in the black cabin. We're just using boards cut to fit for the length of the cabin, nailed right down. Now, I like to use nails as opposed to screws because they look more decorative. They don't look as hokey as a screw holding the floor down. They have more of a rustic vibe, and maybe they'll even rust and bleed into the floor, which will make it look even better. For a plank floor, when you put a good floor sealant on it, just do it when you're not going to be around. Get the floor as clean as you possibly can, apply the sealant, make sure you do a good detailed job around the edges, and then just plan on not being there for a while. Because this is about as good as it gets. This floor sealant is not that bad as far as fumes, but it still stinks, and I wouldn't want to be sleeping in this cabin, especially in cold weather with the doors and windows shut, while this floor sealant dries. Work your way from the far corner back to the door, about the time you're ready to leave, and close her up. Now for the 12 by 12 cabin, I just used a snap laminate floor, just to have something different. Now snap laminate kind of goes together like tongue and groove plywood in a way, but not quite. It's got a hook on one side and then kind of the opposite of a hook on the other, and they kind of set in together, and when you push them down, they just mate up and all lock together. Makes a nice floor, nothing wrong with it. It's pretty fast. You can get a million different colors. Laminate floor holds up fairly well. It's probably going to be good for the life of the cabin. I think they generally have a 15-year warranty on laminate flooring, but that's in a home, a cabin that you don't use all the time. It's probably going to last forever. I thought about using plank in this cabin too, but everything else in this cabin is wood. I wanted something just a little different. Now every cabin I build has a wood stove in it, so that takes care of cooking if you're okay with that. In the summertime, you can always cook outside on a camp stove. In the wintertime, you generally have the wood stove running. Makes a perfect cook surface to put a pan, a pot, whatever on, and a nice slow heat. I've never found the need to run a wood stove so hard that cooking on top of it wouldn't be possible. If you had a stove really, really hot, you could, of course, burn your food. It could be too hot and cook too quickly. But in a small cabin like this, it'll heat up really quick, and you don't really need to run a stove very hot to maintain a good temperature. These little Alpine Camp chef stoves are really very conducive to cooking on. The nice flat top, they're not too big, they're not too small, just a good fit. Now the 16 by 20 log cabin is more of a house, so we put in a small cottage-sized propane stove in that cabin, and it's wonderful. During a summer, a lot of times I'm there generally 4 or 5 months out of a summer, and about a tank, maybe a tank and a half of propane is all it takes to run your cooking stove for hot water, for tea, for coffee, for breakfast, lunch, and dinner all through the summer. A little propane stove like this you'd find on Marketplace under apartment stove or cabin stove. If you're going to check the listings, I would always look at antique propane stoves. They seem to make a lot of these back in the day for smaller living spaces, so it's pretty easy to find one used. They're more or less maintenance free, and the old ones have a pilot light, so you don't need electricity to use them. Speaking of electricity, let's talk about lighting. Now, the short time use cabins, like the black cabin, like the 12 by 12 cabin, like the cabin with a porch, we just light these with a power station and a strip of LED lights. I can be at this cabin for 5 days before I run out a small power station of charge, just running lights, charging my phone, charging my laptop. These strip lights are also a good option. It's basically like a roll of tape with little LEDs embedded in it. You can put it anywhere you want it, hold it in place with a thumbtack. They do have an adhesive backing, but if your cabin is constantly hot and cold, I've found that they don't stay stuck where you put them. So a thumbtack will keep them in place. A strip of lights like this puts off an amazing amount of light, doesn't take a ton of power, and you can put them wherever you'd like them. Now, as far as what the cost is for something like this, the bulb style tend to draw a little more power. They're about $27 for a strip. These are from Harbor Freight, and several versions of the strip lights can be bought on Amazon or at your local hardware store. They're very inexpensive. As for power stations, well, my goodness, the sky's kind of the limit. Every company under the sun makes power stations nowadays. This little Anchor right here is the one I'm running in the cabin with a porch. I charge it up before I go to the cabin, and if I'm there 5 days, it'll generally do all I need for lights and charging phones and such. I get 1,000 emails a year of people wanting me to pitch their power stations, but honestly, I don't know that one's better than the other. So just grab one off the shelf, charge it up, and do what you need to do with it. It's probably just as good as the next. Now that the cabin's mostly done, we can focus on finishing the outside. For the 12 by 12 cabin and for the black cabin, we use T111, which is a finished exterior wall covering and a structural plywood. Use whatever stain is applicable, whatever color you like. I don't think there's a wrong answer here. If it fades over time, put another application on. There's just way too many variables when it comes to staining the outside of a building for me to give you any advice that is going to be universally useful. Find what you like, put it on the wall. When it comes to our 16 by 20 log cabin, it's a whole lot easier because there's not a lot of options out there. Log cabin stain is much more specific than an exterior stain or an exterior paint. What we're using here is a product called Duckback Log Home Oil. And speaking of finishing the exterior of a log cabin and the interior, chinking is probably the last step you're going to do. You can chink first and then stain over the chink, or you can stain first and then chink the joints. It doesn't really matter. We're using a product here called PermaChink. It's a very interesting product. It kind of goes on like a paste, but it's a rubber with also a sand grit to it. It remains flexible even in freezing cold temperatures, and it lasts forever. It'll bind to the log on the left and the log on the right, and it'll bridge that gap, making a really nice tight seal. Now, they do sell this product in tubes like you'd find caulk or construction adhesive, but if you're going to do a lot of area, you're going to want to buy a 5-gallon bucket. This plate I'm putting in is called a backer plate, and it works with a bulk loading caulk gun. You're going to find these sold right there next to the permachink. They're kind of a specific use tool. But when it comes to chinking, the best money you can spend is on this. This is what's called backer rod. It's basically a foam rod. It's the same material you see wrapped around pipes in a basement to insulate a pipe, but it's in more of a string, basically. Backer rod is super cheap, and chink is not cheap. So you're going to want to tuck in your insulation between your logs and fill any big gaps with a strip of this backer rod. Get some 1/4 inch, get some 3/8, get some 1/2 inch. You can pack this rod in. It's going to add insulation. It's also going to fill up that space. So you can either put in 2 cents worth of foam backer rod, or you can put in $1 worth of chink. It makes a ton of difference financially by the time you finish a cabin, whether you've used backer rod or not. Without the backer rod, you're going to be filling these big gaps with chink, and chink is a couple $100 a bucket. But one bucket will do a cabin this size no problem, so long as you go around and fill up those big gaps with backer rod first. Now the bulk loading caulk gun will fit onto this backer plate, and then you just pull, and it will suck the chink up into the bulk loading caulk gun. Then you spread it on just like you're decorating a cake, and once you have it spread over a joint, you're going to go back with a small paintbrush and just a little bit of water, not wet, just dampen the paintbrush, and then you can spread that chink out and make it seat down nicely, touching the log on either side of it, making a very nice grout look between each log. Not only is this going to improve the efficiency of the cabin, it's also going to add some structural component to it too, because it is basically a glue, so it adds strength, it helps the cabin heat easier, and it's also decorative. Perfect way to finish off a cabin, some backer rod, some permachink, and that's about all there is to finishing a log wall. One of the reasons I love logs so much is just the fact that when it's done, and you can walk away. The other end of things would be a framed wall, where you frame the wall, insulate the inside of the wall, put plywood on the outside, sheetrock on the inside, sheetrock mud, paint, and on the outside you're putting house wrap and vinyl siding. There's like 7 or 8 steps to that. Or with a log, the log is done once it's up, cleaned, stained, and chinked.
Well, I hope that this video has clarified some things or maybe given you some good ideas. Good luck on your cabin builds, and don't forget to send me pictures when you're done. If you want to see the long version of any of these builds, check out the playlist up here in the corner. My name's Dave Whipple. You've been watching Bush Radical. Be radical, eh? See you soon.